Hello and welcome. So, we don't have anything big planned for this talk, just a giant blowout party with all the thread information, planned choreography, and a bespoke song. That was the first of many Barbie references to come within our talk. Is your security enough? My name is Mac. I am a detection engineer for Red Canary, and outside of being a STEM Barbie, I am also a runner Barbie and a cat Barbie.
And I'm Rachel Schwalk. I'm a senior detection engineer at Red Canary. And outside of work, I am a bookworm Barbie.
During this talk, our goal is to not only entertain you with our Barbie memes and quotes, but to break down various trending threats, leaving you with actual detector opportunities to implement and test within your own environment. We want to ensure that your security is enough, or maybe Kenough, depending on how you pronounce it. Of course, this is our meme. The Red Canary Threat Detection Report has been released for 2024, and we will be discussing some of the top threats and trends from it. If you need or want more information, we will be giving a link to the Threat Detection Report in the video notes as well. So bear with us because our jobs aren't public speaking, it's just plain security. From the initial access stage to additional payload install, and persistence, we will go over FakeSG, Scarlet Goldfinch, Charcoal Stork, ChromeLoader, and Yellow Cockatoo. I'm going to hand it off to Rachel to get us started with our first threats.
All right, let's talk about FakeSG and Scarlet Goldfinch. So these are browser update themed threat clusters. The naming, as you can tell, they kind of are copycats of SOC Ghoulish. The SGs and the name. SOC Ghoulish is kind of the OG, the original malware in this instance. So Scarlet Goldfinch, it was initially observed in June 2023, leveraging batch scripts for payload download, and it switched to leveraging PowerShell around October of 2023. FakeSG, it uses URL shortcuts, HTA files, and PowerShell for payload download. And both of these threats favor NetSupport Manager as their payload, but they've also been observed distributing other stealers, like Atomic Stealer. Just they typically tend to drop NetSupport more than anything else. Let's talk about initial access of this threat. So it involves traffic redirection from compromised websites, and the users will see a website they'll visit. It may be legitimate, but it was just compromised. It'll pop up a screen like, hey, you need to update your Chrome before you can continue. They'll click that update button and download that malicious browser update file. What does that look like? For these different threats, there's some small differences. So Scarlet Goldfinch, it typically extracts a JavaScript file from the initial downloaded zip file, and FakeSG will typically download a URL shortcut file that will route the user to a HTA file. So an example for Scarlet Goldfinch would be browser underscore update underscore version number .js, and a FakeSG example is like a v103.323.1.hta, so similar, trying to look like a version number of a browser. Initial execution of these threats, so Scarlet Goldfinch leverages WScript to execute that JS file, and FakeSG will typically leverage MSHTA for the HTA file. FakeSG has also been observed using URL shortcut files that initiate execution of 4files.exe, and that executes PowerShell to then call MSHTA. Those were high-level details. Now let's look at actual execution examples. We've got Scarlet Goldfinch, so WScript executing that JavaScript file extracted from a zip file. You'll see in our command line here that it has the original zip, and then you'll have the update browser version number .js. That will then call PowerShell to download an initial payload within a zip archive and also set up persistence through a registry run key. I didn't put the entire PowerShell mess of a command line. It's very nasty and long, but some examples that I pulled from one is that it uses the new object system.net.web client.download string for calling the download from an external resource. And it also has a system.convert from base64 string because it does do some base64 obfuscation in the command line. Now, PowerShell, it downloads the payload. In most cases, like I mentioned, it's probably going to be Net Support Manager. And so that looks like client32.exe. And Net Support Manager, it's interesting because it is also used legitimately by some companies for remote management. But in legitimate cases, it's probably not going to be running out of app data roaming, which is exactly what Scarlet Goldfinch does. So you'll see client 32 in this random folder, and then callbacks are made to the rat CNC server or additional malware is downloaded at this time. How does that compare with FakeSG? So FakeSG, the initial access is a little bit different looking with the URL shortcut file to launch MSHTA. In this example, it was like trying to look like a English update package.url, and that called MSHTA to visit this malicious IP address and download an HTA file. That then used PowerShell to download our next payload and create a scheduled task to run it log on. Again, the PowerShell was quite a mess, so just some examples of what was used in the command is new object system.security.cryptography.aes managed and new object system.io.memory stream, and then it also used the same from base64 string. So it's got a lot of obfuscation and encryption going on in this command line and also executing in memory. And so then that download, whatever it is, sometimes it's Net Support Manager, like in this instance, it is installed and again, app data roaming. So legitimate instances, probably going to be in program files. In this instance, app data roaming. And similar to Scarlet Goldfinch, then we have the opportunity for more malware to be downloaded or callbacks are made to the rat CNC server. Let's talk a little bit more about the persistence that was briefly mentioned. FakeSG was observed using PowerShell to create a scheduled task to execute when the affected user logs in. So we've got this action variable, and it is making a new scheduled task action to execute that client 32 binary. The trigger is going to be at logon, so when the user logs in, client 32 will open up and execute and connect back to the CNC server. And then it registered the scheduled task under the task name background check. So trying to kind of blend in and not cause a lot of head scratches on what it is. It's like, no, it's fine. It's a background check. Don't touch it. Scarlet Goldfinch does similarly. It actually uses registry run keys instead of the scheduled task. So it calls PowerShell to set up it's calling itself Office to execute client32.exe and the software Microsoft Windows current version run key. And kind of similar, trying to blend in, naming itself Office. Maybe you'll think it's related to a Microsoft Office task. Well, it's not. So similar persistence mechanisms, also trying to just blend in, but something you need to keep an eye out for. And both of these threats, straight to jail. Scarlet Goldfinch and FakeSG, no good. All right, let's talk about detection opportunities now. So we've got scripts that executed from built-in Explorer zip functions. If you look for a parent of Explorer executing WScript and including a user's temp and the command line and a .zip and a .js, That should be enough, but if you need to, you can also add a requirement that it has a network connection. And then you can also look for WScript executing a JavaScript file from the app data folder. So process of WScript and regex matching app data ending in .js. We've got some PowerShell detection opportunities that would catch both of these threats, along with quite a few other threats, because PowerShell is one of the most used tools by adversaries and admins alike. But in this case, if you look for PowerShell, including a command line with that download string, that's something to investigate. You know, if you see something going to an external resource and downloading through PowerShell, good opportunity to look at what's going on there and what's being downloaded. We can also look for PowerShell using that new object and from base64 string. If you have some obfuscation going on through that from base64 string, that would catch both of those threats that we mentioned. Some more, this one for FakeSG, but it would also be a great opportunity to look for other malware. MSHTA spawning PowerShell. You've got that process, MSHTA, and the child process PowerShell. That shouldn't typically happen and should be pretty high fidelity on its own. And then hinted at a few times is net support running out of an unusual directory. So if you don't use net support legitimately, you could just detect on any execution of client32.exe. If you do use net support in your environment, at least look for it executing outside of program files. So that would help catch the persistence that might be put in by these threats. Now I'm going to pass it over to Mac, talk about our next threats.
All right, so Charcoal Stork is what we call a PPI provider, otherwise known as a pay-per-install. It really drew attention in like 2002 when it began delivering ChromeLoader. So ChromeLoader is a browser hijacker. It modifies the victim's browser settings and then redirects user traffic to advertisement websites. We kind of distinguish the difference between Charcoal Stork activity through its installer file names and hashes. So default file names for Charcoal Stork is something like your file is ready to download, or commonly we see just install. Talking about initial access. So first, early Charcoal Stork examples were ISO files with payloads leading to multiple phases, including a Node.js-based app and PowerShell commands that achieve persistence and then install ChromeLoader. Then in 2023, Charcoal Stork payloads began to evolve, and in addition to the ISO files delivered in 2022, we observed Charcoal Stork delivering a variety of file types, VBS files, as well as MSI, EXE files. And so what first started as a very obvious trend of your file is ready to download, like I mentioned previously, it shifted to a generic name of just installer. Since then, Charcoal Stork campaigns are distinguished by the same binary hash, appearing under a lot of different names, such as ones that contain wallpaper alerts, which I didn't even know that people were still downloading wallpapers and not using, a picture of your cat or a picture of your family, as well as other installed generic names. As we've mentioned, there's a lot of different ways that Charcoal Stork serves as a delivery mechanism. At first, we track the initial lure and dropper separately from the payload in order to determine maybe there's multiple actors involved. But the volume and the success of delivery from Charcoal Stork just couldn't be ignored in terms of ChromeLoader. So in this example, we are showing Charcoal Stork dropping ChromeLoader. A lot of Charcoal Stork payloads consist of just a browser extension is designed to redirect search engine queries. However, with ChromeLoader, the payload includes all the components required for that backdoor access and code execution. Your file is ready to download. It's presented as a disk image. This is downloaded from and ran, dropping the payload for ChromeLoader. We see this dropper executing from the, again, like Rachel mentioned, it's that app data roaming folder. And embedded within the .exe binary from the initial dropper is nw.exe. It's a software component of nw.js. The script nw.js then allows developers to write native applications in HTML, JavaScript, and then further allows Node.js modules to be called directly. Basically, this just provides application runtime to allow the executable to make successful external network connections to then, of course, malicious websites. That established persistence as well as then dropped archive bat files. These unzip various DLLs, they're extracted into the, again, app data roaming folder, and then that persistent mechanism you'll see over and over again, it adds registry run keys, all while the browser hijacking just continues. Stork is responsible for the delivery and installation of ChromeLoader, as well as other payloads. We've been seeing it delivering additional payloads like Smashjacker, which I don't mention in this actual execution chain, but it's very prevalent as well, and we will touch on some detection opportunities for that. As mentioned in the execution chain that I just showed, ChromeLoader establishes persistence by putting a shortcut .link into a Node.js-based app in the startup folder. Both ChromeLoader and Stork have been observed establishing persistence via a registry run key, and we have an example of both of these techniques on this slide. So you can see on the left, or my left, the startup folder, and then on the right we have the registry run keys, and you can see we provided a little snippet of what that may look like depending on what the naming is. And of course, relevant to both the naming conventions of Stork, despite the argument between the Kens, both naming conventions are legitimate indicators of this dropper. On to detection opportunities, which are maybe the most important part of this talk, right? Something that you can apply to your own environment. On my right, we have the detection opportunity for ChromeLoader side of Stork. We want to detect on the unique ChromeLoader nw.js runtime app installation path. Again, that app data roaming. If you can use binary metadata, that's even better. It can definitely help you reduce false positives. The next detection opportunity is to alert on the specific file name. Again, your file is ready to download. If you want to use install.exe or whatever that extension is, you can, but obviously that's a more legitimate name for some installers, despite not being very specific. So that's why we recommend using your file as ready to download, things like that. And I did briefly mention that ChromeLoader is not the only payload that Stork delivers. I mentioned Smashjacker. These opportunities are to catch potential behavior related to that. It's also a very prevalent additional payload delivered by Stork. So first we have the detection of the app init DLL installation. One persistence mechanism used by some variations of Smashjacker was the app init DLL. It would use a reg.exe command to create appropriate Windows registry keys, and then that would maintain its persistence. And then finally, our last detection opportunity for ChromeLoader and Stork, we have the detection of the web browser loading extension. So again, this is related to Smashjacker specifically. So during execution, Smashjacker forced Google Chrome or Microsoft Edge to open with the command line argument --load -extension. So a browser extension can basically install without any user interaction. This will likely uncover additional adware in your environment. It may need to be tuned to take into account like acceptable software installation and things that are allowed within your company or environment. Coming in at number 4 for the 2024 Threat Detection Report is Yellow Cockatoo. It's an activity cluster involving a RAT, or a remote access Trojan. It filelessly delivers various malware modules. So although the public covers a lot of the later stages in this threat, earlier behavior in this intrusion chain is very notable. It's the installation mechanism that delivers code and then runs persistently. So that code downloads and executes additional modules that are never written to disk. So that can translate into InfoStealer, VNC module. We also want to emphasize that the search engine redirects, which enable Yellow Cockatoo, it allows this threat actor to compromise users at scale. And moving into that initial access, which by Yellow Cockatoo often occurs via, again, the search engine redirect. It directs a user from a legitimate search engine to a site that downloads a malicious file. The file utilizes this is a pretty cool part actually. It utilizes the victim's search query as its name. So, for example, if you're searching super cool cat, the example or the exe would be supercoolcat.exe. So it has a little hint of social engineering, and it uses this because victims may be more inclined to engage with its content. Yellow Cockatoo is unique in its ability to dynamically customize its attacks by doing that based on victims' real-time searches. The query-based binary installs a malicious payload. It's typically a .NET-based DLL. It's stored in an encrypted state, either in a file on disk or in the Windows registry. The execution chain starts with, of course, that initial access through the search engine redirect that I just talked about. The user is directed from a legit site, then it goes to the site that downloads a malicious file. So after installation, the executable spawns a command line, and that creates a temp file, and that launches PowerShell. So in order to execute this payload, Yellow Cockatoo leverages obfuscated PowerShell commands, reads in the encrypted payload, decrypts it, then reflectively loads it into memory. Similar to our previous threat, the code continues to run persistently, and then later on it executes additional modules. That leads to the execution of malicious DLL. It's a remote access Trojan, again a RAT, implemented as a .NET assembly. It's designed to be loaded into memory. You're going to hear Rachel and I throughout this talk hit on persistence again and again and again, because it's very similar, but it's a good way. So when we give you some of these detection opportunities and things like that, you'll notice a trend throughout all of these threats. And although it's similar, they each tune it just a tiny little way, but the detection opportunities can help you catch multiple of these attacks. So for the persistence here, we frequently see adversaries using, again, like admins, PowerShell, but in this case, it writes malicious.link files into the startup directory. With Yellow Cockatoo, this persistence mechanism eventually launches the command line script, and then that leads to the installation of those malicious DLLs. Moving into the detection opportunities, again, the one TTP that is remaining consistent with Yellow Cockatoo over the years is the use of the Windows startup folder for persistence. It's not unique to Yellow Cockatoo, so again, like I mentioned, this detection opportunity is likely to identify multiple threats, multiple persistent mechanisms in these threats. We are detecting on the process PowerShell, and then a command line including the string app data, again looking for the app data roaming, as well as looking for a file mod with the path start menu, programs startup, and then you can add the extension .link. For our second opportunity, we've seen Yellow Cockatoo loading suspicious .NET methods. Primarily, those are seen in PowerShell script load content. Again, behavior is not limited to Yellow Cockatoo. It can be applied universally for malicious PowerShell obfuscation attempts. And just a side note, not every EDR has the ability to detect on this based on our logic, but you can also try looking for this in the command line and not just the script content. We recommend looking for the process PowerShell, finding that script load containing AES crypto service provider, or from base 64 string, or you can do user32.dll. And much to the dismay of Yellow Cockatoo, Rachel and I are giving you all of the tools to detect them. This is everything. We are everything. Yellow Cockatoo is simply just Ken. I don't want to accidentally Ken-splain to all of you. Loving these Barbie puns. So I will hand it over to Rachel to talk more about RMM tools and some ways to prevent these threats as well.
All right. We talked a little bit about it earlier, but remote monitoring and management tools. If you do not have any rules when it comes to the use of RMM tools in your environment, I will look sad and cry because they have been a very much increasing trend used by adversaries. Why though? Because they're legitimate tools on their own. So a lot of times they can go onto an endpoint and really not have anything show up as abnormal. It really lowers their chances of detection before they get what they want. What tools are we talking about? We already talked about Net Support Manager, already seeing 2 threats that utilize that. We're also talking about Screen Connect, TeamViewer. There's actually so many out there. There's new ones coming out all the time. So there is a list out there through this open source tool surveyor, and you can see all the different remote admin tools, like really more of the more popular ones used. There are, new ones all the time. It's really hard to keep up with them, and that's kind of why it's really important to establish a baseline and make sure you have certain RMM tools that are authorized and allow list those while you don't allow any of the other ones. So allow listing is going to be most effective, but you can also block the major ones and try to, whack-a-mole it that way too. Surveyor's really great at also looking at your environment and seeing what you have running currently. So if you don't have a way to do that yourself, use Surveyor, really cool open source tool, and it can also have more definition files available other than just remote admin software. If you don't take into consideration the RMM tools, really, it could be catastrophic. Let's talk about prevention measures now. We've gone over detection, but what about preventing it before you need detection? So here are some options. So you can set default applications based on an extension. So one of our favorite examples is that .js file stuff, those JavaScript files. You can set the default application to open in as a notepad. So, if you have a super user, they may know that that's probably not what they want, but a typical end user, that will probably stop the attack in its tracks. We've also mentioned application allow listing and block listing. Allow listing, I know it's hard to do sometimes, so if you can't do that, then at least try to do a block list of the major RMM tools. And then also blocking newly registered domains and domains with unusual top level domain names, so like .xyz. Putting in an ad blocker, just a simple one through Chrome, really can do wonders for preventing the search engine optimization poisoning attacks such as yellow cockatoo. There's also the option of disabling auto mounting of disk image files. So if you have a .iso file and a user clicks on it, typically it will auto mount into another drive on the Windows endpoint, but you can also set that to just be disabled through GPO. Enforcing download restrictions is another important one for, maybe not all users need to be able to download exes or .js files. Yeah, you can make those restrictions through the browser admin interface, or you can create GPOs for that kind of thing as well. And last but not least is user education, letting them know that certain file types are harmful, similar to the phishing education everyone does, letting them be aware that things that come from the internet are not always as they appear. Even if you're looking for cool cats, probably don't want to click on coolcats.exe.
Oh, come on.
I know, such a bummer, those security people. So what else can you do? You can test your detections. So we've got all these opportunities. We want you to implement them, but you should also be testing. What do you see when certain behaviors execute? So spin up a PowerShell session and put in some weird base 64 that says hello world and just enough to what you expect your detection to trigger on, and make sure that you see into that activity as you expect. There's a lot of tests out there already made for you, so it's really simple. Copy the command lines that's given, and there you go. You should be able to set this up without any effort. Key takeaways here. So We want you to implement those detection opportunities, but validate using atomic tests from Atomic Red Team. Tune the logic to be high fidelity. If you have a bunch of false positives, whenever a true positive comes in, you're probably going to miss it because, oh, 9 times out of 10, that's been nothing. I'll just move past it again. And also ensure that visibility into the behavior, because if you don't have good visibility, that's another reason that you might hide that badness. You'll see it and you'll be like, well, I don't know, I don't see enough. So make sure you have the visibility you need to make a proper decision. Monitor for persistence as well. All of these threats we've mentioned have persistence techniques. So scheduled task, you can monitor for new scheduled tasks, look at weird files in the startup folder, and monitor changes to the run keys in the registry. And of course, lastly, download the Red Canary Threat Detection Report. We go over these threats. We go even over more threats and also other detection opportunities. And it even includes links to the appropriate atomic tests within that. Thank you all for listening.